What is going on, everyone? Adam Allard here with Pragmatic Ways, and today we have another refactoring video going over some refactoring of some code. I saw someone post this question on sort of how to code this program in some Facebook group, and then myself and a bunch of other people commented basically saying, "Oh, well, we're not going to do your homework for you. Show us what you've tried, what you've attempted, everything else, where you got stuck or confused, and then we can help you from there so you can solve the problem instead of us just giving you the code." And this person did that, and they came up with the code, and they actually completed the assignment too. This is the assignment here, and what I have right here is the actual code that they came up with. So now I'm going to be taking this code and refactoring it, taking it or looking at it from rather a perspective of a developer who's been in the field for a number of years now. And again, just sort of applying some basic refactoring stuff, really cleaning up this code and showing you all just some quick tips on how to make cleaner code, how to refactor code, make it easier to maintain, so on and so forth, all that great stuff. So a link to the Facebook groups I'm referring to will be in the description below, as well as links to the GitHub account, as well as the blog, pragmaticways.com, where all this stuff will be included. So without any further ado, let's actually jump into what we're talking about here. So the program that this person needed to complete is as follows. You were driving a little too fast, and a police officer stops you. So we need to write a method that will compute the following result. 0 equals no ticket, a 1 will equal small ticket, or a 2 will equal big ticket. And the way to determine what size ticket you get, what integer to return, is if the speed is 60 or less, then return 0. If the speed is between 61 and 80 inclusively, then return 1. If the speed is 81 or more, then return 2. Unless it's your birthday. If it's your birthday, you're going to get a little bit of a leeway here. So if it's your birthday, then your speed can be 5 miles per hour higher in all cases. And then they give us a couple of examples here of some sample inputs with the expected output. All right, so I'm guessing they want us to create this caughtSpeeding function here, and it's going to accept two arguments. The first one's going to be the actual speed, and the second one we're assuming is supposed to be some boolean if it is your birthday or not. So in this case, 60 and not your birthday, it would return 1, so you would get no ticket. The second case would be 65 and still not your birthday, so that would be considered a small ticket, so it returns 1. And then the third case is 65, but it is your birthday, so that bumps it up a little bit. We get a little bit of that 5 mile per hour bump for the leniency here due to our birthday, so that would then return 0 for a no ticket. So we'll go through here and see what this person came up with. All right, we have in the main function here just the 3 different test cases that call this caughtSpeeding function. And that's defined right here. A public static void, caughtSpeeding accepts the int, and then the boolean is birthday. So it starts off with if is birthday, then sort of do the logic for if it's the birthday. Speed is going to be 65, else if greater than 65 but less than 85, then do this, return, or output rather instead of return, but output 1 for the small ticket. Else if it's greater than 86, then return the 2. Else, if it's not your birthday, we'll then just do the normal speeding limit. So under 60, no ticket. Between 61 and 88, return 1. Clearly we can see there is a bug here. That should not be 88. That should rather be 80. And then, and again, this is just, I literally copied everything. The formatting, I copied 100% everything from what I saw in the example above. So that's why I'm just explaining that there. And we'll clean that up later, of course. And then else, if speed is greater than 81, then output the 2. All right, so now it's time to dig into this and start actually refactoring it. Now, the first thing I'm going to do is I'm first going to format it. We can see there's a lack of consistency in the formatting. Like we have a space right here, but no space here. no space here. I tend to like spaces in between there, such as like this inside my conditionals. All right, but I'm not going to go ahead and manually do that. No, that's we are developers. We like efficiency, so I'm going to let my IDE handle this for me, and I'm using IntelliJ, so very easy to do that with. I'm just going to go to code and then reformat code, and it makes it all pretty for me. If you're using Eclipse or NetBeans or anything else, they have very similar features to do that as well. So I'm just going to go ahead and save that, and I don't even need to rerun this program, because actually that's I'm going to do that right now, because that isn't something I did right off the bat. I'm going to run the program just to verify that this program does work the way it is intended to. Given our sample test cases here, we should receive this sample output here. We get the output of 0, 1, 0, just as we would expect. So we know this program works as intended, at least for the sample input here. All right, so like I said, the first step was to reformat it. Now let's actually dig into what we're actually going to be doing here. So the next thing that I really want to be doing here is I don't like, we already saw that there's a bug here, so I don't like that all of these are just they're called magic numbers. That's one of the code smells that we talk about when we're talking about refactoring. Get rid of all these magic numbers. When we see a 60 here or these 88s, they don't really mean anything. There's no real context behind them unless we have to go all the way back up and really understand the business rules. And as we're going through code, as we're scanning code, like you guys scanning code right now, not really knowing the true business rules, or we come back to it later down the road and we're trying to remember, like, oh yeah, why is this 60? Why do we need 61 or 88 here? Just seeing these random hard-coded, these quote-unquote magic numbers, it makes all this logic sort of in our head, and we need to find a way. Martin Fowler, the author of the Refactoring book, actually says this exact point. You want to take that logic out of your head and bring it back into the code. So one way to get rid of magic numbers is to create symbolic constants for them instead. So that's what we are going to do. Right at the top here, I'm just going to extract out these speed limits, and I'm going to create them into symbolic constants instead. All right, so to save you all the trouble of watching me type all that through, I just went ahead and copied and pasted that in here. So I just created a couple variables here. And I didn't actually make them constants. I should have put the final keyword in here, but I'll show you why I didn't do that later on. But for all intents and purposes, we can consider them as constants right now. But I just actually declared and initialized them. I'm not actually using them yet. So let's go ahead and do that now. And we are going to replace these magic numbers with these variables that we created up here. All right, so instead of 60, I'm going to say if speed is less than or equal to no ticket max speed. And then small ticket min speed, this is going to be the small ticket minimum speed here. And then this will be the small ticket maximum speed up here. And again, that's where the bug that I was talking about came in before. This person typed in 88 instead of 80. So then we replace that with our variable that we declare up here. And then for the last one, big ticket minimum speed, 81. I'm just going to replace that magic number with that right there. All right, and just off the bat, I could rerun this right now, and we should expect that this program should not change at all, but it's always great to, periodically verify that your program still works in the intended way as you're going through refactoring. Again, Martin Fowler really harps on this, is change a little bit, test a little bit, change a little bit, test it, make sure, you didn't break anything as part of your refactoring. Refactor each step in small incremental steps and test after every single change to make sure that that little change that you just didn't break anything. Because it's a lot easier to fix a change when you only change a little thing at a time. All right, so now with those ones taken care of, what we can do is actually replace these magic numbers as well. So instead of putting this in here, like I could do something like this. I could say the variable +5 for every time, right? Because that's what we're doing. Let's say if speed is less than no ticket max speed plus 5, because again, if it's your birthday, we get that extra 5 miles per hour leniency here. Instead of doing that for all of these, that whole plus 5, that's definitely duplicated each time. That gets repetitive. So instead, what I'm going to do is I'm going to create a function that's essentially going to automatically do that for us. So I'm just going to, if it is your birthday, the first thing we're going to do is adjust speed limits for birthday. All right. Now, the problem with doing this right here is that because I would have to create a new function for this, well, these variables here wouldn't be within the scope of this function. So one way I could do that, one way I would have to do that in this particular example, is I'd have to pass in all 4 of these variables into this function here. And I just don't really like the idea of doing that. So really, I'm going to be taking a completely different approach here. All right, I'm going to be creating a separate object for a ticket. I'm going to create an object that's going to hold, I'm going to create an inner class object to hold this sort of ticket ID that we have right here. And this ticket's going to hold, these, and then it's going to hold these speed limits. It's also going to hold the sort of formula to determine what size ticket you get, if you get no ticket, a small ticket, or a big ticket. And then on top of that, I'm going to create a second object that's going to extend from ticket, and this object is going to be able to modify our original variables here. So let me undo a couple of these things here to get back to the state that I was at, which is right here. All right, and now let's go into the actual better creating these objects and everything else that I want to do. But before I actually do that, I just realized one thing I also wanted to note was this function here, caughtSpeeding, was marked public when realistically it should be marked private. And that's another key thing when you're refactoring or even just writing code in general, is always try to keep your scopes and your functions and your variables as private as possible. You don't want to be broadcasting and making everything global, making everything public. Try and keep everything as private as possible. And this is definitely a case where only this main class really cares about this caughtSpeeding function here. So we're just going to make it private. No one else outside of this class needs to know about it. And now with that out of the way, now let's go ahead and actually create that inner class that I was talking about. So I'm just going to create a public static class, and this is just going to be named ticket. All right. And then I'm going to copy in all these variables that I wanted up here, and I'm going to bring them down here. And I should, again, mark them private, but because, like I said earlier, I wanted to create a subclass of this ticket class for a specific ticket on birthday class, instead of private, I'm going to make these actually protected instead. So I'm going to Control-C those and bring it back down, Control-C, bring it back down, Control-V rather, all right? Now that I got those all in there, next thing I want to do is I want to create some sort of getTicket function. All right, so I'm going to say public, and it's going to return an int. That's actually something else I should have mentioned, is that these functions here, this function in general, should really be returning the int. And actually, let's go ahead and do that now. Before I even do any of this, I'm going to go ahead and copy out all of this right now. Comment out all of this right now, rather. Sorry, not copy. Oops, okay. There we go. And now I'm going to make this whole function return an int instead, because that's realistically what it should be doing. So instead of system.out.print0, I'm just going to say return 0. And then, of course, instead of print1, it's going to return 1. Else if that, it's going to return 2 for the big ticket. And then same thing down here, return 0. Have a lot of duplicated code here that will get cleaned up in a bit. Here's return 1, and right here will be return 2. And I'm going to get a compile error here, and it's missing a return statement. And essentially why that is because in each of these if-else statements, I have a else if, but there's no actual else, because if it's not this or this or this, it doesn't really know where to turn. Now, again, logistically speaking, it has to be one of these given just the way our logic is represented, but the compiler is still going to complain about that. So just for a quick fix here, I'm just going to return -1. Now, realistically, I should be doing some assertion fail or throwing some exception type of thing, but just for a quick dirty thing, for this specific case here, I'm just going to return -1, make it nice and simple, and that gets rid of the compile error for now. All right, oh, and now that that's out of the way, what I really should be doing here is creating these test cases, as in something like this. I'll say int ticket1 equals, and actually assign the result of this function here to an actual variable, because I believe that's what the instructions actually said, is that write a method to compute the result, 0 equals, so yeah, so the result is 0. So I guess it doesn't necessarily say that, but this here as well, when it's pointing the arrow to that, I'm really just assuming that this function should return this value. So that's why, in my mind, this should be returning a value instead of just outputting it to the screen. All right, moving on, continuing on with this, Control-C, Control-V, Control-V, and then change those to 2 and use case 3, ticket 3. All right, and yeah, I guess really a use case would be a better word, huh? Use case 1, and then use case 2, and use case 3. All right, control save that again, just a quick little control run here just to make sure we're still doing everything correctly. See, now it doesn't output because now I need to system.out.println. Now I need to print line down here, which again is no big deal. It's just I want to follow the instructions I want to follow the program per the actual instruction requirements, and that was supposed to be, this function should be returning a value. But now I could say print out use case 1, print out use case 2, print out use case 3. All right. And there we go. Now I should be able to rerun this program and watch the magic happen. And it should be the same. Yep. 0, 1, 0. So everything still works. So now let's continue on with actually creating this ticket class, this ticket inner class that I was referring to. So again, right now we're going to be creating this getTicket function, and this getTicket function is really going to be handling the real logic for determining what type of ticket we need. And honestly, what I could really just do here is copy this exact conditional right down into here, because that is literally what it exactly is. So I'm going to go ahead and save that. And now that this ticket class is working essentially the exact same way that this is, what I'm really going to be doing here is I can now just completely delete this, and I'll create a new ticket object equals new ticket. And now I'm just going to return ticket.getTicket. And I'll pass in the speed because that's what it needs. And again, control run this. Make sure everything still works out the exact same. And it still does. We're still getting the correct output that we are expecting. So now I want to take this a little bit further though. And now I am a big fan of extracting out conditional logic into their own functions. So it's just a little bit easier to read. So instead of saying speed is less than or equal to no ticket max speed, what I'm really going to do is I'm going to create another function here. This one's going to be private. It's going to return a Boolean, and it's going to be say is no ticket. And again, it's going to accept the speed here. And this one's just going to return exactly what this says right here. And that's just going to return what that conditional was supposed to be. And now I can replace this actual logic here with that conditional function that I specified. And now it just reads a little bit easier. And now I don't have to try and think of what this is actually doing. I can just say if is no ticket, return 0. And then else if is small ticket. So I'm just going to copy this function here, and I'm just going to is small ticket. And it's going to be very similar. It's just going to return this conditional instead. And again, now I can replace this conditional with this new beautiful function here. and pass in the argument speed here. And then exact same thing for under that for creating a big ticket is big ticket. And that's going to be this conditional here. So I'll come down here and replace u with u. And then go up here and replace u with u. And control save that, control run that again. Make sure, again, that everything works as we intended to. And beautiful. Still working great so far. And again, now it's just a lot easier to read. Get ticket for a certain speed. If is no ticket for the speed, return 0. If is small ticket, return 1. Else if is big ticket, return 2. Else return -1 for some type of error error code, I guess. Again, I'm not a big fan. I'm not any type of fan of returning -1s or error codes or nulls or anything. I'd much rather throw an exception or assert false or something like that, you know. But again, for this specific use case in this sample program here, this will suffice. So now that really that does the ticket portion of it, but now we need to create the logic for if it's a birthday. And we should notice here that I have this structure of code, which looks very similar to this structure of code. So I still have duplicate code in here. So now I need to figure out a way to sort of reduce this duplicate code. And the way to do that is I'm going to create another inner class here. And this one's, again, going to be the public static. This one's going to be called a ticket on birthday. And this is going to extend our original ticket class. So public static class ticket on birthday extends ticket. Okay. And I want this one to have a constructor. So I'm just going to do a public constructor, and then I'll call super. That way it instantiates everything for our super class here, our parent class. But now what I also want to do is now I can do this, what we wanted to do originally, which is going to be adjust the speed limits for your birthday. So I'm going to say adjust speed limits for birthday. And what this will be is a private void function. And all this is going to do is it's going to increase each of our speeds by 5. So again, instead of saying +5 for everyone, what I really want to do is put that into a variable. That way it's easy to change if for whatever reason we need to drop it down to 3 or bump it up to 10. I'll need to change it in one place. I'm just going to say int adjust speed by equals 5. And now I want to just change all of these, and I'm lazy, so I'm just going to be doing something like this here. Delete all of these, just so I could copy them in quick. And there, now I could do plus equals adjust by speed, and Control C, Control V, Control V, and Control V. There. And honestly, that's all I have to do for this entire function here, or for this entire class, because now this entire class will work the exact same. It's just now it adjusts all these speeds by 5. All right, so now I actually want to use this class inside of our original getCaught function here. So if it is the birthday, well, then I can just delete all of this code, and I'm just going to say ticket on birthday, ticket equals new ticket on birthday, and then return ticket.getTicket for the speed. And control save that, control run that, and then this should work, again, the exact same, and it does. So that's great. I can actually delete these variables now, and it really cleans up this function. And I'm almost done. There's still a couple more things that I think we should do here. First off, notice how this and this, they still look pretty similar, don't they? There's still some duplicate code, duplicate logic in here. And the way we can actually fix this is essentially sort of polymorphically creating this ticket object, because really this ticket on birthday is still a ticket object. So what I'm going to do instead is I'm going to just declare just a ticket up here. I'm not going to instantiate, but I'm going to declare it. And now I can say in here, well, if it's your birthday, well, ticket's going to equal a new ticket on birthday. And I'm going to take that out. And then else, if it's not your birthday, well, then ticket is just going to equal a new ticket. And then I'll take that out. And then after the fact, I will return the ticket.getTicket. And now it's going to delegate to either the ticket on birthday or just the ticket. And again, it's going to go through the exact logic here. If it's on the birthday, each of these will be incremented by 5. Else, if it's just the base ticket, the parent class ticket, it's just going to be on these results here. And again, I'll control save that, control run that again, refactor a little bit, test a little bit, refactor a little bit, test a little bit. Whole clockwork there. And again, we still get the exact same output. And now very super duper close to being done here, but there's still one last thing I want to do. And I might get a little bit of quibble from other developers on this, but this is just a personal preference that I like to do. We still have magic numbers in here, and it would just be a tiny bit more clear if I would extract out this logic into an actual constant or named variable as well. So I could say int, and really I could this time say final int no ticket equals 0. And then that way now it says return no ticket instead of return 0, and it just helps provide that tiny bit a little bit more context there. All right, and then I could say final small ticket equals 1, and then this would return 1 or return small ticket. And then same thing, right down here, big ticket equals 2, and then return the big ticket. And then else again, final int error code. I'm not a fan of using error codes, as I will continue to mention, but whatever. And control save that. Command or control, actually that's all command C and command V on a Mac, but then control R for a run in IntelliJ, and again the output comes out the exact same. And now I think I'm actually done here. I think I have the program working the way I actually would like it to here. I think it's actually pretty clean for the most part. All right, so now let's go through this code again, just to basically walk through everything, so hopefully we can try and understand what we did a little bit better. So we have 3 separate use cases here. We're only really just going to follow one of them. First thing we do is we have a speed of 60, and it is not the user's birthday. So we're going to pass in these arguments here into this caughtSpeeding function here. And all this is going to do is it's going to declare some sort of ticket. We have some sort of ticket. We know that it's either going to be a ticket on birthday or just a regular ticket. All right. If it's the user's birthday, well, then we're going to instantiate this ticket object as a new ticket on birthday object. And all this is going to do is, it extends ticket, so it gets all the public functions that ticket gets, as well as the protected variables. And what this does then is it calls the super, and then calls the parent class to create everything. And then it calls our own private function here, and all this does is increment all of our speed limits by 5, because on your birthday, as per the requirements, we can be a little bit higher. All right, and then that brings us back to up here. So now we have this new ticket here, which equals a ticket on birthday. And then we're down here, and then it just returns the ticket.getTicket. So if we jump into what this actual function does, it goes by the speed, and it says if is no ticket, return no ticket. Else if is small ticket, return small ticket. If is big ticket, return big ticket. Else return an error code. It will never even reach the state anyway, so it really doesn't even matter. But just to, again, take a quick peek inside what these private functions here do, is no ticket if speed is less than or equal to no ticket max speed, And again, this just works because if it's the ticket on birthday, well, this no ticket max speed has been increased by 5. Else, if it was just a regular, if it wasn't the birthday, it would come in here and it would just create the basic ticket and it would be going by this value instead. So then else, if it's small ticket, if the speed is greater than equal to the minimum speed for a small ticket, and the speed is less than or equal to the maximum speed for a small ticket, if it's within that range inclusively, then that's going to return true. So if true, then return the small ticket. Else, if is big ticket, if it's greater than or equal to the big ticket minimum speed, will then return the big ticket value, which is the 2. And that's it. That's all I got for you guys. I hope you enjoyed this video. I hope you learned a little bit here. I hope you learned a thing or two about how to refactor, using some polymorphism here, learned about extracting out magic numbers, replacing them with named constants or even named variables, just to help give it a little bit more context and value behind it. Extracting out conditional logic into its own named function. It helps, again, just really helps reveal the intent of what it's trying to do here. And it takes that sort of mental logic that we had to think about and really paints it into the actual code itself. So now we can actually read what's going on through actual, English is no ticket, instead of having to think like, okay, what is this actually doing? Oh, it's making sure that it's less than the maximum speed for a ticket, right? So it just, again, it's all about clarity. Clarity is really king when it comes to writing good, clean code that's just easy to maintain, less error prone for other developers coming in and trying to screw something up that you might have written months ago, or even yourself. 6 months down the line, you come back in here to update something. When things are named easier and it's a lot easier to read, and you just have so much clarity in your code that it's just super easy to read, there is a significantly less chance for you to introduce a new bug when you're trying to change something. So again, if you like this video, please smash that thumbs up button. Please consider subscribing to get updated for more great content like this. Learn about more refactoring tutorials or some other design patterns type of things. Learning more about Java, so on and so forth. Visit our blog at pragmaticways.com. Join our Facebook group, the Software Engineering Mastermind group. And until next time, happy coding.